has over 25 years of experience in the welding industry and is currently the Segment Management National for Welding Automation Projects at Fronius India Pvt Ltd, which oversees India and SAARC countries. He is an AWS Certified Welding Inspector and began his career with Fronius Kolkata in 1998. He worked at L&T-Eutectic-Welding Product Business for 11 years, rising from application specialist engineer to regional manager, and then at Linde India Limited as manager application development in welding, laser, and heating technology. He has performed various welding technology training programs. Mr. Saha will share his expertise on robotics and automation in welding.
From 100% subsidiary company of Fronius International based in Austria. And we have three business divisions: Perfect Welding, Solar Energy, and Perfect Charging. So total 8,000 people. We are working for a business turnover of around 1.6 billion euro. And we develop technologies to resolve various industrial challenges in all three business units of ours. We hold 1,600 plus active patents, which defines the capability of our R&D for innovation in technologies and processes. Fronius India headquarters is located in Pune, and we have a dedicated solution and skill development center for our industrial customers and academia, that is academic institutions, engineering colleges, universities. We work closely with them. We also have various regional centers located at various parts of India, that is Gurugram, Ahmedabad, Mumbai, Bangalore, Chennai, Hyderabad, with capabilities to demonstrate robotic welding as well as automation welding. So under our group of Perfect Welding business unit of Fronius, we offer total solutions starting with manual welding of various processes as shown, like MIG-MAG, MMA, TIG, plasma, as well as robotic welding solution systems and total solutions with robotic as well as hard automation. Hard automation means it is manipulator-based, column and boom, and basis where we do not use robots. So these are hard automation systems. So we develop those. So Fronius Automation offers total solution, like a single source from a single source. That is, the complete responsibility lies for the system, its performance, and also after support, everything from the same company. So these systems involve robotic systems as well as hard automation system. As I mentioned here, we develop softwares and hardwares for complete requirements, including controllers and programs. So coming to today's topic, at this stage, I would like to just emphasize about the welding is a complex process and highly dynamic process involving many variables. Welding is always a challenging task, be it a manual process or be it an automated or robotic system. So some of the welding challenges are mentioned in my slide. I will just maybe read some of them. Like selection of the right welding parameters. This is very important. Maintaining the arc gap steady throughout the welding, achieving the desired depth of penetration as per joint strength requirements. Welding of special metals like high strength steels, material without distortion, thin material welding, welding of ferrous, non-ferrous, and various other. That means every welding is different. Welding at open site, that is a pipeline or structural fabrication, is another, brings in a lot of new challenges. Positional welds like 5G welding, 6G welding, shortages of skilled workforce across all sectors in the industry, higher demand of production and higher expectation of quality, rework and rejections also increases the cost. So all these put together makes a range of challenges, brings us in front of us. Also, there is a robotic welding challenges to bring the right solution for the individual needs. So when we talk about robotic welding challenges, before that, for giving the solution, we must have an intelligent welding system. So Fronius has developed the intelligent welding system, which has got smart cards, device IDs. So these parts, basically, they generate data and they also detect and enable devices to detect the various components attached. So with this, it makes it possible to work for IoT enabled, ensuring traceability of every operations as well as documentation. This slide shows a typical robotic welding setup with the peripherals of a welding power source. Accessories for a push MIG-MAG system. So push means wire feeding is unidirectional. So here we can see, apart from the robo, which is put in a gray color, it can be any make robo, but the other systems which are very important were interface as well as the welding process, softwares, programs, all are integral part of the system. Similarly, push-pull system, which is basically cold metal transfer, where we are able to do thin material welding as well as overlay. So these kind of systems also have a setup requirements like this. But talking about welding challenges, like robot teaching. So if we have any robot, the teaching is always a time-consuming process. During teaching, many times we are not able to maintain the stick out. Wire gets touching the component and it gets bent. And every time we have to cut the wire and reset the stick out measurement every time for a proper teaching. So in this kind of complex components, in this video, we will share So with the help of an intelligent system, teach mode makes it very easy. So no additional cost, time saving, and no rejection rework due to wrong teaching. So this is the advantage, a benefit to the customers. Talking about the next challenge is seam tracking. Another challenge can be part fitment issues for thick plate welding. So in the picture, you can see a big bogie frame, which is normally carrying the coaches or the wagons in a freight wagon or in a passenger train. So in these kind of components, we always do not get the possibility of a fixture, proper fixture. Many times welding is done using an open tack welded component. Part tolerance, the issues could be there. Robot program versus or against robot programming path, actual job deviations could be there. So single, or it can be a single wire or a double wire or a twin wire process, and various joint configurations could be there. There could be some are T joints, some are butt joints. So various options are available. So what is the solution? We call it a task. TASK, task means through our SIM tracking also. So we have done this task function test at our center in Pune. So it is with a Fanuc robot, it was tested. So in the first video, we can show the dry run, that is the teaching path, and in the second one. So here you can see the plates are not tack welded. It is just kept so that we ensure or expect there should be a distortion or there should be a deviation in the path. So during the actual welding, we can see when the welding started, the actual welding path is shifting and the robot is getting a signal through the smart intelligent machine that there is a change in the path, and accordingly the robot arm is getting shifted, which does not allow the welding to be defected. So you can see the welded piece when the welding path has shifted, even but the welding line has not shifted, the joint is done. So this kind of feature is possible using the intelligent feature from the equipment, and this is with a no additional cost, no additional optical measuring device like cameras are not required. So here we can see the customer benefits are immense, no additional cost, time saving, and no rejection or rework. Next challenge is basically for thin material with a robotic, where the part shifting, edge variation, fitment gaps are the challenges. So when we are doing thin material, these are the challenges. Like we have put some of the components on the screen. So we have the technology called wire sense. So with wire sense function of the push-pull drive in robotic system, it is possible to detect the edge position, unwanted gap, detection of the sheet thickness between 0.5 to 20 millimeter. No additional optical measuring device is required. Moving on to the engineering or construction sector, where the welding challenges are further difficult. Welding challenges at sites are outdoor for large parts, where positional welds are there, multi-pass welding, accessibility issues. Robotic may not be possible in all the applications, so hard automation systems are also playing a big role in these kind of sectors. When the power source is intelligent and it can communicate with the hardware or hard automation system, it can create a perfect weld. We have some here welding carriages are able to do welding. Here we can have two photos. There are videos, but because of the time paucity, I am not playing the videos. We can see the operator. I am not talking them welder because welders are getting upgraded as operators. They are no more holding the torch. They are no more welding by their hand, and they are far a little gap away from the welding arc and fumes. Skill issues are taken care by the intelligent power source and sensors. Welding fatigue issues are taken care by the welding hardware or carriage. Then results are high productivity and less defects and repairs, and ROI can be achieved in a short time. Another big challenges are basically big components, welding of tanks, vessels in manufacturing industry, process equipment industry. So here we can show a typical arrangement for a circular seam welding and also maybe a long seam welding for this kind of automations also possible. Also, it is very much used in modern industries. Another important application, small tubing for process equipments like heat exchangers with high precision requires a TIG orbital. So I just want to conclude my presentation with few points, like an intelligent welding system can produce a defect-free welds. Robotic automation and SPM automations for welding reproducibility will largely depend on the selection of the right welding process. Skill shortages issues can be partly addressed without affecting the quality and productivity. And last but not the least is the changing mindset about welding automation. It's different, definitely, but it is possible.